Okay, so take a look at the notes that I gave you. Okay, do you see on the note paper, on the note paper it says, finding the zeros of a polynomial function help you factor the polynomial, graph the function, and solve the polynomial. We have done this by factoring quadratic functions previously. So this method is not new. So if you look at example 1, it says factor x cubed minus 2x squared minus 15x completely. So, Sophia, what's step 1 in factoring?
Find it or look for the GCF.
Look for the GCF. So, Chris, what's the GCF on this one?
Oh gosh.
What do they all have?
They have X.
They all have an X. So then I'm going to factor that out. Now, the X is going to stay out front, okay? That X is going to stay out front. That's not a big deal. But then I go to the inside, and it's a trinomial. And now we're familiar with 3 terms as a trinomial. So I'm looking for 2 numbers that multiply to negative 15, but add to a negative 2. Yeah, Jacob? Negative 5 and 3. So now watch what you're going to have to do, okay? I've got to leave the X out. Don't drop it. That's one of the most common mistakes I see is students just drop the GCF. It's still there. So this is going to be x squared minus 5x plus 3x minus 15. Okay, so I'm doing the split the middle method. So if you know what you're doing, keep motoring on ahead of me. Now I'm going to change this maybe to a bracket. This is what this big one is. Because now I'm going to use a parenthesis. That's x times x minus 5. This is a plus. I have a 3 times x minus 5. You can either use a parenthesis, and you just have a giant parenthesis around everything after the x. Now, I don't need that anymore because I'm going to factor out the x minus 5, and what's left is x plus 3. So what we're going to be doing in chapter 5 is we're going to have more complicated polynomials that will have GCFs and then they continue to factor. All right, so if you look at the slide below, there it is, it's worked out. Okay, that second slide is just, I just did it there. So now go ahead and flip the page because that isn't anything new. There it is, it's already worked out. So now it says, polynomial zeros and X intercepts are the same thing. So what I'd like you to do is I want you to circle this right here. The polynomial zeros and X intercepts are the same things. When a polynomial is set equal to 0, you're finding the zeros or solutions. So here's what I want you to do. I want you to write some things down. B is a 0 of f of x, and f of x is going to be our function. Okay, B, that's going to be like the answer, okay? B is some number. B is a root of an equation, f of x equals 0. So B is a 0 of a function. B is called a root if you have an equation. B is the x-intercept of a graph, f of x, if I graphed it. And then watch this. This last one is really neat. I'll kind of pause to make sure you're up with me here. So B is called a 0 if you just have a function, like on our warm-up. That was just a function. There was no equals, okay? B is a root if you have an equation, and B is an x-intercept of a graph. Now this last one, And I'm going to have you do an example. X minus b is a factor of, and I'm not sure that makes a whole lot of sense. So let's do this. If x equals 2 is a 0, then x minus 2 is a factor. And think about this. Think about what we did in chapter 4 with our quadratics. You remember when we factored like x minus 2 times x plus 3? And when we went to solve it, it was x is 2 and x is negative 3. It's the opposite because you would really be subtracting the 2. So this is going to be important. So I know this copied sort of weird, but if you look at the slide below, it says find the zeros of x plus 2 times x minus 1 times x minus 3. Then we want to graph it. So, Edward, we're going to kind of answer your question again for you. Everybody got that? All right, so if you want to find the zeros, you set x plus 2 equals 0 because it's factored. X minus 1 equals 0, and x minus 3 equals 0. Please, please make sure you're bringing your graphing calculator with you to class because we're going to have a quiz on Tuesday next week, and it requires a graphing calculator. So either borrow somebody's or something, and you need to be practicing with that graphing calculator. So my zeros are x is negative 2, x is 1, or x is 3. All right, now, what I want you to do is let's go to those graphing calculators, okay? And we're going to go enter this, and we're going to get some values. Do you understand that these zeros are the x-intercepts? Okay, the zeros are the x-intercepts. So I've already got them, and now I'm going to kind of piggyback to, what Edward asked me is, like, how do you graph? I'm not quite sure what to do. So watch what we're going to do. Take out your graphing calculators, and I'm going to open a new document and add a graph. This time, it's written differently. I have parenthesis x plus 2, parenthesis x minus 1, parenthesis x minus 3. So you do enter it just the way that you see it. Okay, everybody got it in the calculator? Anybody need help? This is on your page. Okay, this is on your page.
What's the website called again?
Desmos.com. D-E-S-M-O-S. Yeah, so if you don't have a graphing calculator for now, use that, but on the quiz, you can't use your laptop. All right, now, and what's cool, do you see here's negative 2, there's 1, and there's 3. Like I can see the x-intercepts. Let's see if you can, do you see you can just drag it down a little bit too? Okay, what we're going to do is we're going to find this maximum up at the top, and we're going to get the minimum down at the bottom. So let me refresh your memory. So you press Menu, Analyze, and let's go get the maximum. That one's on the left. And I'm getting negative 0.79, 8.21. Okay, I'm going to round 2 decimals. Then let's repeat. Menu, Analyze, and now I need the minimum. It does not matter which one you go get first. And I got 2.12, negative 4.06. And I'll put those on my, on my paper here. So I'm going to write here, I had the maximum is negative 0.79, 8.21, and I would like you to get in the habit of labeling them minimum and maximum, because that's going to help us. So the minimum was 2.12, negative 4.06. When you look at the graph, what's the end behavior? the end behavior? Where is it far to the left? Where does it go, up or down? It goes down, and then on the far right, it's going up. So what you're going to do then is you're going to plot the x-intercepts, and the x-intercepts are the zeros, and then you're going to plot the min and max, then use the end behavior to help you put it together. So here we go. I have an x-intercept at -2, an x-intercept at 1, and an x-intercept at 3. Then let's estimate. And here's a minimum. Okay, so it's down, comes up, and then the end behavior says it shoots back up. Now, even though I didn't ask you here, let's do it anyway because it's going to be on the quiz and on the review and on next period's homework. Let's talk about the increasing and the decreasing, because I know yesterday it was still a little foggy for a few of you. So this increases on the left until it hits the maximum. Let me say that again. The graph is increasing on the left until it hits the maximum. So we use x values. So it's -infinity until I hit -0.79, because that's the maximum. And that's why you want to label them max and min, okay? That'll help. Then it's going to increase again from the minimum to the right. And the minimum x value is 2.12, and to the right goes to infinity. Not because it goes up to positive infinity, but because I'm going to the right forever. I'm using the x values. Now it decreases from the max to the min. So the x value of the max is -0.79 to the x value of that minimum. All right, so Edwards, did that help?
Yeah.
Okay, so again, when you want to graph a polynomial, you're going to find the x-intercepts and the max and mins, plot those, use the end behavior to figure out what direction it goes, up or down at the ends. All right, when you're ready, flip to the last page, and that first slide is the answer, okay? And that's exactly what we got. On the bottom half, we're going to do one extra problem, okay? We're going to do one extra problem. Everybody okay with this part?
Yeah.
Okay, so that was it. We already did that. All right, here, I want you to put an example, and we're going to put this one here. It says, write the polynomial function with zeros, x is 2, x is 0, and x is 1. Okay, so write this down. So, this is 0. What was the factor before we got our answer? Does anybody remember? What would it be? Like, what was the line above? It's like, I gave you the answers, now I want us to work backwards to get the equation. Okay, if x equals 2, what was it above it? X minus 2, right? Okay, so we're going to write x minus 2. This would be x minus 0 and x minus 1. So it's going to be subtract whatever that number is. So if it's a negative, it becomes x minus a negative, which is a plus. So this is called the factored form. And make sure you're writing this down, because we'll do this a little bit more tomorrow. But for today, this is what we're just identifying. It is called the factored form. Now, what would you need to do to put it in standard form? Standard form is if I multiply it out. Well, x minus 0 is x. So I'm going to rewrite this now as x minus 2 times x minus 1. And let me ask you a question. If I said to you, I want to do 5 times 6 times 7, would you take 5 5 times 7. No, that's not the distributive property, right? Okay, if I have 5 times 6 times 7, you do 5 times 6, figure it out, and then multiply by 7. So guess what? That's what you're going to do. You're going to take x minus 2 times x, figure it out. That's x squared minus 2x. Okay, because I'm actually multiplying. I know you see the differences and you want to distribute, but it's not x minus 2 times x and x times x minus 1. That's not true. Now, I'm going to FOIL. X squared times x is x cubed. The outer is negative x squared. The inner is minus 2x squared. And the last is a plus 2x. Can you collect like terms? So this is giving me x cubed minus 3x squared plus 2x. And this one is now in standard form. So you have factored form and you have standard form.
What was the 5 times 6 times 7? What was that?
Oh, do you see that when I do x minus 2 times x minus 1, I have students who want to take the x times this and the x times that. And that's not true because if I had 5 times 6 times 7, you wouldn't take 6 times 5 and 6 times 7.
Right.
You do the first two together and then take that answer times the last. All right, that finishes the notes.
Let's go.